Well, hopefully by now you're getting used to taking the natural logarithms of exponential functions. What I'm writing down here is just the radioactive decay relationship. We have the A, which is a function of time, is equal to A0, the initial radioactivity, times e to the minus lambda t. Lambda is a decay constant. The minus sign tells us that this is the radioactivity is decreasing exponentially over time. If we wanted to solve this equation for lambda or t given some other values, we should be able at this point to write the result down directly. Now this I know is is still something that you are probably working with. If we take this term, here, let's just realize that what we're taking here is the log of a different a in this case, times b, a log of a product of two numbers. We know that this is the log of a plus the log of b. And b in this case is equal to e to the minus lambda t. So this is like some other combination of numbers. This would be like maybe a c to the d power. And if we were to take the natural log of c to the d power, we would take this exponent d and then bring it down in front. And this would be equal to d times the natural log of c. Well, c in this case is equal to e. So is equal to the base e. So lambda t is our d. And so we would just, what we're saying here basically is that we have e to the minus lambda t. We bring the exponent down, we have minus lambda t times the natural log of e. Now, all this is really asking us, when we are taking the log of a number, we are getting the number that we have to raise e to in order to get e. So what power do we have to raise e to in order to get e? Well, we know that e to the 1 would be equal to e. So the natural log of e is just going to be equal to 1. And so we would write this result as the natural log of e to the minus lambda t. It's just equal to minus lambda t times 1, or just minus lambda t. So that's how we get this term over here in this relationship. Now we also have worked with other exponential decay relationships. We've talked about how the porosity drops off as a function of depth due to compaction. This phi 0 here would be the initial porosity at 0 depth, let's say, and then this phi would be a function of the independent variable d. And you should again then just be able to write this down as the log of phi is equal to the log of phi 0 minus lambda z. You should be able to explain how to do this. You should be able to explain this relationship that we've highlighted over here. In other words, the rule says we bring down the exponent out in front, as we have here. And then we take the log of this quantity e. In this case, ln tells us that this is the natural log, or the log base e of e. So the question we're asking is, what power do we have to raise e to in order to get e? Well, That's just 1. And over here it's the same question. We do have a kind of a hidden part of the result over here is, taking this exponent down in front and then realizing that and just kind of dropping the log of e term, or letting it equal to let it equal to 1, so that we get natural log of phi 0 minus lambda z. Okay, there's one other relationship that we talked about. This is an element concentration equation. We have C0 times the liquid fraction raised to the d minus 1 power, and this d is it's a distribution constant. And if we wanted to transform this into a linear relationship, we'd do the same thing. At this time, let's just take the log base 10, because we don't have a base e over here in this expression. F is actually a variable in this case. But when we're taking the log, we've got the log of a product of two numbers. So we've got the log of C0 plus, and we'll have the log of F to the d minus 1 power. Okay, and then we just apply our rules. We've got the log of C0 plus, and then we'll bring down the exponent, d minus 1, and then we've got the log of f. Now, f in this case is not a constant, and it's not a base. It's our independent variable. So we pretty much have to leave this in here. In this linear relationship, log of f is our independent variable. In the equation, the straight line equation, y is equal to, let's say, b plus mx. Just to put it in this form, our x in this case would be log of f. Our m would be the distribution coefficient minus 1. And our intercept would be log of C0, with y being log of the element concentration. So again, you should be feeling pretty comfortable with these kinds of transformations that we're working with. Hopefully you are. If you have questions, make sure you bring them up.